for JOBIM to invite me to give this presentation. And I've made the presentation available at this tiny URL. So those of you who want to read along with me, please do, because I'm probably going to speak a bit fast. Okay, so I want to talk to you today about FAIR computational workflows. So if I can make my slides move, yes. So these days, we see a big resurgence or adoption of computational workflows for data-intensive bioscience, because we are in a world of having to prepare and analyze and share increasing volumes of complex data. And we've seen that at this conference. So several examples here of the sort of thing I mean, where we're putting together a series of different steps in order to be able to do some sort of data-intensive analysis. In CRI-M, image analysis, for example, from the Instruct project in Europe, metagenomic pipelines from the EBI and Elixir, drug discovery, protein ligand, molecular dynamic simulations from the BioExcel project. And also this morning we heard about genome annotation from Brahman using the workflow system called Galaxy. And we heard Fabrice talk about high throughput sequencing using the Nextflow workflow system. So we see this kind of pattern of computational workflows where we're stitching together tools using completely different systems. And all of these use different kinds of systems. I mean, computational workflows have been decades in the making. As Sarah mentioned, I led a project called Taverna, which is now really nearly 20 years old. So computational workflows, and we called them scientific workflows in the old days, have been going for at least 20 years. This is a summary paper from about 14, 15 years ago. But now they're beginning to become much more mainstream, maybe finally coming of age, just because we see the scale of computational processing that we need to do. So they're appearing in popular press. And also this new paper here by Titus Brown's group, if you're really interested in reading about how to streamline data-intensive biology with workflow systems, I recommend this paper. So excellent paper. So what are data-intensive computational workflows? Well, it's kind of a systematic linking together of multiple tools and software packages. So here's a picture, a classical picture. There's some inputs, there's some outputs, and in between, there are a bunch of steps. Now, the key thing about a workflow is that it separates out the specification description, that's the actually what your instructions of what to do, from the software execution using typically some sort of computational engine, a workflow management system engine. And that means that the specification is all about trying to abstract away from the actual implementation. So that means that we can get scale out. So you can kind of devise flexible workflow composition to construct these kind of executable control and data flows, but using heterogeneous tools made by other people. So we want to be able to put things together. So we need to describe how to put those things together without getting bogged down in the details of the actual execution. And then we can also then deploy or sort of separate out that execution to enable scale up. So we have access to computational infrastructures, we can do handling the interoperability, the processing, data wrangling, and so on. So it's a separation of concerns in order to be able to get the benefits of scale up and scale out. So here's a couple of examples, or I want to show a particular example why this is useful. Here's an example from the Galaxy project, Galaxy Europe, as part of Elixir. Where these variant surveillance workflows have been developed, taking in data from the national data resources, including the UK COG UK, which is our COVID surveillance organization, combining that with the public data sets, doing a suite of analysis, variant calling, and so on. Those workflows are available for everybody, and then we're able to put the results into national dashboards, interactive notebooks, other databases. And so the point here is that we're getting, by having these processes, we're getting improved data quality, we're getting uniformly analyzed data, we're getting clean submission of data to public archives, and we're also spotting where people have done processing incorrectly. So this is a very powerful mechanism. It goes every 3 hours, runs over the UK viral database, the sequence databases, and the COG UK databases represent nearly 50% of all of the sequence databases in this field. It uses a computational network called the FAIR+R network, which includes Genuist as a partner providing computational resources. And really, it's operating as workflows as a service platform, really designed for direct use by end users. But experts have built these workflows so that other people can use them. And that's a really important sort of scale out issue, that you can build these workflows, you can design these workflows, you can run these workflows, but then other people who aren't you can then use them, interact with them, and be able to customize them for their own needs. And you can also keep a complete history of what you actually did. Those workflows are registered in a Workflow Hub registry, which is something that I'll be talking about later on. They're published, and you can find them, you can cite them, you can use them as scholarly objects in their own right to be reused, recycled, and repurposed. And indeed, Jacques this morning told us about how these workflows now have been incorporated into the infrastructure for the French surveillance, genomic surveillance and research initiative, Imagen, where he talked about the fact that he'd reused and adapted and these workflows that we just told you in order to be able to quickly and rapidly assemble a computational framework in order to be able to support genomics surveillance. This is important because it's basically reusing expertise and tried and tested and reviewed pipelines for the benefit of others. So the thing I found quite interesting about Jacques' example was he's actually using multiple workflow systems and execution platforms. And it's an intertwined workflow landscape that we operate in. It's not just one set of workflow systems that we work in. There's scripting environments, so we all use Python and other scripting environments. There's interactive electronic research notebooks like Jupyter Notebook. And then there's also workflow management systems dedicated to this, to workflow design and execution, and their assistant execution platforms. So typically is RStudio in the scripting world, Jupyter Notebooks, and Google Collaboratory, and then 298 and counting systems for workflow management. And these are all mixing and matching. So you might do some interactive and exploratory analysis using your Jupyter Notebook, and be calling production automated workflow integrated software from that notebook that's implemented in another workflow system. These then have the workflows are registered in repositories, or they're registered and they're managed in repositories. The community typically GitHub based, and then they're registered so that you can find them. This would be ideal. And it also means that they can then feed into the scholarly communication world, such as Zenodo, OpenAIRE, and so on, because these are also scholarly artifacts in their own right. So I made a slide that has 10 handy properties of computational workflows, which is why they're so useful and so important. They have this notion of composition and abstraction, and I'm not going to go into the details of this. I'm just going to do the headlines, and particularly handling the heterogeneity of using different third-party codes, but you can use the best codes. They shield the workflow designer and the workflow user from complexity, and they allow you to really create reusable and remixable methods. That's a key point about abstraction and composition. They enable you to reuse, and they also enable you to adapt so that you can try out workflows with your own data, bring your own data, your own parameters, and really kind of disseminate that kind of knowledge, as well as being able to support things like repetitive, reproducible pipelines, simulation sweeps, and handle all the kind of data and control flow that comes with that kind of automation. You can also, because the workflow management system underneath is doing all the heavy lifting, you can have, you can design your workflows in order to be able to access infrastructures and really support optimized computational and data handling, including parallelization, and also including secure access, because you can build that into the environments that you're operating under. And of course, there's also, as you're systematizing the processing, you're also systematizing the reporting. So you get auto documentation, which is important for accreditation, and the portability aspects as well. So these workflow management systems do a lot of work on dependency handling, containerization, and enabling you to move your workflows between on-premise and cloud infrastructures. So there's a whole range of different workflow management systems. They go from sort of frameworks and rule-based, sort of effectively graph-based workflows that you can run in your own platforms, such as Snakemake, through to Galaxy, which is kind of more like an online portal where users are encouraged to build and reuse workflows that others have developed. But there's a lot of work in having those tools wrapped up, or the pre-installed tools all being wrapped up. Of course, you can run your own installation of that. And then there's things in the middle, you know, Nextflow, which has kinds of sort of graph-like properties, but it's also, there's increasingly portals so that you can be able to run workflows as a service. The take-up of workflows typically depends upon what's plugged in, what's the availability of the components, what kind of codes have been actually wrapped so that they can be incorporated in the workflow, the skill level of the workflow developers, and popularity. Popularity is probably the biggest one. So Vive la France, you've got a whole bunch of different workflow environments, including lots of Galaxy installations. So there's Galaxy France, use Galaxy France, which is a portal for the French community, which I think has around about 2,000, 1,500 registrants already. There's the French ecology Galaxy installation, which is to do with the natural history museums. And there's also a instance which wraps up other workflow systems, so workflows that are written in the workflow language 9 that are then called from the workflow system Galaxy in order to be able to do synthetic biology and industrial biotechnology. And that's led by Jean-Luc Vallon. Yes, it's a lot of work. Yes, there's work here because, you know, it's not just knocking up a script, but labor saving is actually labor shifting. So really, we're talking about a spectrum of users of computational workflows, from the folks who are actually building the systems and managing the platforms and managing the infrastructure, through to workflow application users where the workflow has been pre-cooked. They may be just calling it from a portal, but they can use all of that expertise and all of that power in order to be able to create systematized production level science and processing. So there's a kind of spectrum here of using workflows as a sort of platform, as a workflow developer, and workflows as a service, if you will. But at each point, we need infrastructure services, we need tools to be wrapped and maintained so that they could be called in the workflow. We need the workflows to be developed and tested and run and maintained for yourself or for others. And you also need to go and find and understand those workflows with explanations to be able to use them properly. You know, how should I set my parameters? What kind of data should be included? That's all the kind of spectrum of needs that we have. But we can see that although the labor might be high in managing a workflow management system, the reach is extensive for the users of it. So it's where you position the labor of a workflow system. Now, in the European Open Science Cloud Life project, which I'm heavily associated with, including Elixir, which is the European research infrastructure for life science data, which again, I'm very heavily involved in. We're trying to build a collaborative space for digital biology in Europe, really taking that sort of spectrum that I just showed you and saying, how can we create an environment that builds those kind of platforms, makes them available so that more researchers can then take advantage of the power of workflows and take advantage of workflows that have been pre-developed by others. So the EOSC Life project is a wide-ranging project. It has about 13 research infrastructures ranging from compounds to genomics to tissue banks, plants to marine to humans, all working together to try to build effectively a data and method commons. Now I have a normal slide I would put here, but I've stolen Roman's slide from this morning because I really liked it, because it basically says this is what the EOSC Life project is all about. It's building an environment for hosting and processing research data, hosting and processing research data to support science. And really here we're looking at tailoring that world for life sciences. So we're building a workflow and tools collaboratory, which means we will be able to host those tools on this cloud, as it were, and we will be able to register their existence. We will be able to make them available to folks. So it's a kind of data and method commons, if you will. And I see it as workflows as being an entry point to the tools and data sets that are being hosted and enabled in the European Open Science Cloud, and as functions for producing production quality FAIR data and enabling access to secure data processing. So I see that workflows are actually the way into the European Open Science Cloud and the way into collections of tools for folks who may not be so familiar with those tools. This is a picture of the EOSC Life Workflow Collaboratory. It's a confusogram. So you could see this is what we've actually assembled, and we have actually assembled it. So it's got registries, it's got workflow systems, different kinds of workflow systems, not just one. Remember, there's 298 out there. We've got the whole use of containerization. We've got different repositories that go with the different workflow systems and so on. So I'm kind of going to use this as examples of when I'm going to be talking now about the notion of FAIR workflows. So we'll be kind of working our way through all of this kind of infrastructure. But it's really I wanted to illustrate here that the EOSC Life Workflow Collaboratory is trying to serve not just tool developers and workflow developers, but the end users and the systems administrators. And the other thing I wanted to make clear is it's not a greenfield site. So up to now, computational workflow framings have typically, and I've just done exactly the same, framed in this kind of way. They've framed in the sense of workflows are really handy for reproducibility and replication and regulation. They're labor saving, they give you greater productivity and reliability. They're knowledge sharing, and that knowledge could be adapted, so you can specialize them, customize them, but they're kind of scholarly objects as well. But also I want to frame it as a kind of democratization of computational analysis and methods, that if workflows have been developed by Elixir, then Jacques could pick them up and use them. And that's a kind of democratization. And if workflows have been developed for a community and presented in a platform, then folks who are not familiar with how to make those tools work can then use those workflows. And that is democratization of analysis. So a different framing that I'm going to use in the rest of this presentation is about FAIR, findable, accessible, interoperable, reusable, which is kind of a mantra that has taken grip of science research generally in Europe, in the USA, in Australia. It's really kind of hit a nerve. The FAIR principles come from originally from a paper that was published in 2016, which I am a co-author on, which came out of a workshop in 2014, about really to give some guiding principles in order to be able to enhance the value of digital resources and their reuse by people and by machines. Okay, so this came from an activity where we were trying to get access to data primarily through automated mechanisms, i.e. workflows, in order to be able to access it. And it was extremely difficult to do because many data sets are, if you could find them, weren't actually computationally accessible, and certainly their metadata wasn't computationally accessible. And it was really about aligning a community around a journey to creating common data guidelines, and with the idea that you'd be able to accelerate science if folks could actually find and reuse and interlink the data of science. And of course, that also applies to other objects, not just data. So they could find and interact and reuse and interlink tools and workflows as well, so that everybody would benefit. And since then, it's really taken off. It's taken off to the extent that it's now a fundamental core of the European Open Science Cloud and its interoperability framework. It's actually the glue that federates all the data and services applied to all objects of the European Open Science Cloud and the Horizon Europe projects associated with that. And there's an entire collection of major activities around this. Go FAIR, CoData, the Research Data Alliance. These are all organizations that are promoting FAIR in the scientific community, as well as amongst policymakers and funders. Now, I'm sure you, like many, if you had read the FAIR principles, I'd be surprised. You've probably heard of them, or maybe you haven't. Hardly anybody has read the paper, although it's cited about 4,500 times, but that doesn't mean anybody reads it. So what do the FAIR principles actually look like? Well, they look like this. Now, I'm not going to ask you to read them. I shall be sort of pulling out points as I go along in my keynote. So this is kind of what they look like. You know, here's a principle, here's a principle, here's a principle. You know, data should be described with rich metadata. I mean, this is pretty unremarkable stuff, guys. It really is. So given the basis that it's too long, didn't read, what is it really about? And this comes from the INCF website, which is the informatics site for neuroscience. And it's about enhancing the ability of machines to automatically find and use data or any digital object and support its reuse by individuals. And what it comes down to is you need some persistent human readable and machine actionable metadata. You need metadata to be linked together, and you need to use community standards. You need persistent identifiers, clear licensing and access rules for getting hold of data, protocols for getting hold of that data through machines, and you need to register and index your metadata and your data. That's it. That's really what it is. So it's pretty unremarkable. This kind of things have been talked about for 30 years at least, but we introduced the word FAIR, and that word made a huge difference. And that word was invented not by an English speaker, but by a Dutchman, Bernd Mons. So once you have FAIR data, then you can have also FAIR software. Software is a digital object as well, but research software is not just data. So there is a whole bunch of activities around developing what would be the FAIR principles for software as well as for data. So so we wouldn't just take data and cross out the word data and then put in the word software in our FAIR principles. And so there's a lot of activities led by the Research Data Alliance in partnership with the Research Software Alliance and Force 11 about what is FAIR for research software. And currently their recommendations are being cooked. And I've put a link in the slides where you can go see them, but I'll be referencing those in the rest of the talk. And of course, France has been well ahead of the game on this. I think it was yesterday, the second plan for the national open science in France was published. I'm sure you've all rushed out and read it. And to save you the time, I have or at least I got a translation, and it basically puts software on a par with publications and data. And it also announces a whole number of measures designed to open research software and to better recognize software development in research, including, for example, reaffirming support for software heritage. And of course, in France, you have, to my knowledge, the first certification agency for scientific code and data as well. So France is, vive la France, well ahead of the game when it comes to recognizing the value of software. There are some implicit assumptions in these data principles, software principles. First, that the data and software are first-class objects, and there will be sharing, which of course is a moot point, but not a topic for this talk. That the prime responsibility in those principles was aimed at creators and providers for the benefit of consumers, but not really consumers, users of data or users of workflows or users of software. But consumers need to show the responsibility too, primarily and importantly, for giving credit to the objects that they use. And it also assumes that you'll be operating in an ecosystem. You have to adopt these things at scale. And that means there's a lot of legacy that they have to be adopted into. It is not a greenfield site. And I mentioned that with our workflow collaboratory. There are hundreds of workflow systems, although, to be honest, only about 10 to 15 are really used outside of the labs that invented them. And there's hundreds of data sets. There's of the order of tens of registries. So you're not operating in a place where you can completely reinvent how everybody will work, reinvent standards, reinvent everything. It's got to operate in a world where things already exist, and it has to be adoptable and adaptable. And that means not just providing technical infrastructure, but also thinking about the cultural and community practices around adopting it, and also the policy and processes that drive the technical infrastructure adoption and development, and the cultural and normative adoption of these kinds of principles. And that's what we have to operate in the EOS Glyph FAIR workflow collaboratory: technical, the policy, and the cultural dimensions, which are kind of all oiled by the grease of skills. So let's look at the FAIR principles for workflows then, and I've worked with Sarah a little bit on this. We've published a paper together, and so what can we say? They are hybrids. So they are both method data objects and software objects. So one can look at them as software because they have to run. So that means the principles can be revised. But they're also sort of descriptions of method because of this abstraction. So they're kind of data-like method objects where we can adapt the data principles actually, and don't think of them as actually executing objects. And then they're also instruments of creating fair data. That is, can we show that the data principles are actually supported by the way that the workflows and the tools that they run, the software packages that they orchestrate, are actually supporting the data principles, as they are, largely speaking, data intensive processing engines. So it's kind of, there's a three-way thing around the FAIR principles for workflows. And really the kind of, the software aspect comes down to the properties of workflows, as opposed to just being software by their very workflowness, which is their issues around composability, reusability, and processing of fair data. So I mentioned right at the beginning that one of the really cool properties of a workflow system is abstraction. And this actually really becomes important when one is talking about FAIR, because you have this description. You have a description of the workflow as a sort of precise description of steps, which you may actually have some sort of graphical representation. There's there's no need to have a graphical representation, but you have explicit descriptions of parameters, explicit descriptions of the inputs, outputs, maybe guidance associated with it. And then you have the software execution, which is all of the composited processes with their data being consumed and produced by each step. So this is actually where the software piece happens. But you also have a whole bunch of associated objects, the test data, the history logs, the input data that you put into perhaps a production run, things like who made it, what's the license, sample parameters, test services, so test engines to check, does this workflow still work? Other related workflows, checker workflows that are kind of benchmark that the workflow is still producing the data that it claims to produce, given the fact that some underlying piece of software or infrastructure has changed. So they're actually these multi-tiered objects. And the specification and description level, we can treat them as methods, just as data methods, actually, expressions of methods. But at the software level, execution level, we have to treat them as software objects. And then the second piece that's really important to workflows, that's I think separates them out from other kinds of software, is their composition, their compositionality. That the whole idea of them is that you should have components that you can plug together like Lego, and those components have to be portable. So one has to be able to put them together and run them in different infrastructures, and be able to perhaps package the whole piece together as also a portable collection of objects. So this kind of abstraction and composition really kind of affect what we've got to do when we're thinking about FAIR workflows in the EOS Glyph workflow collaboratory. So this means that to cope with these hybrid kind of data objects, we need to think about the fact that they have composition, and that means that they've got dependencies and parts, and each of those have to be fair to some degree, that they have this abstraction, so we can have a fair specification and fair implementations, so we can treat things differently there. They're living and reusable parts and wholes, so they're going to be objects that will be changing, they'll be versioned, they will also be pulled apart and repurposed, because they are designed to be pulled apart and repurposed, because that's what we do with workflows. And they have to be usable as well as reusable, so they have to actually run, and they have to have good quality, and they have to be mature enough to be able to be used. So this is not just FAIR, this is FAIR+R, so FAIR plus reproducible, or FAIR++, FAIR and also maintainable with high quality. So what have we done in the EOS Glyph project in order to be able to address these kind of constraints? Well, the first thing is we have to make them findable and accessible. So we have a workflow registry called the Workflow Hub, which I co-lead with Frederick Copens from Elixir, Belgium. And there we are really treating these objects as workflows as recognized digital objects of scholarship. But we recognize also that they're going to be changing. So we have to support things like versioned identifiers, we give them DOIs, you can make collections of them, you can build workflow libraries. These can all be managed by the registry. And the registry has to deal with any kind of workflow. So it has to be workflow system agnostic, and it has to also work with publishing services so that it bridges between the workflows and the publishing services. It also has to be very generous with all these workflow management systems to support them to various different levels. And so the workflows will already exist. They already are being produced in their own native places, in their own GitHub environments. We already have container registries, we already have tool registries, we have deployments like Galaxy Europe, like we mentioned at the beginning, which is a massive deployment, which has something like 32,000 users. So we need a metadata state standards framework that can cope with dealing with all of this different environment. And we also need to perpetually develop this in the open to keep everybody on board. So here's a little example of the Workflow Hub. This is actually one of those COVID workflows from Galaxy. Of course, you could do searching. It manages versions and status. It enables you to access the workflow. It gives authors credit. It gives licensing, other analytics, and you can point to other workflows. And in fact, the project isn't just used by EOS Life, it's used by a whole bunch of other communities as well, included the COVID-19 data portal from the European Union. What's the biggest challenge? Well, metadata, because it's always a challenge is metadata, getting hold of metadata. So one has to work with all the workflow management systems to auto-extract metadata. So it's made at the point of creating the workflows or running the workflows. And we also have to provide additional metadata services to acquire metadata, because people don't do metadata of their own free will. The Workflow Hub is more than just a list of workflows. It's also a kind of community of workflow makers trying to also be linked up with workflow users. So we expose, for example, discussion channels. So this is for the BioExcel workflow community, where they have various different discussion channels on Slack and so on. So you can directly communicate. They also have citations, so you can cite these workflows, giving them a DOI, because it's important to begin to get the reciprocity right. What we don't want is that you can go to a registry, you can find something, you can get it, you can use it, and then you don't credit it. So consumers have quite a lot of responsibility in this environment, as well as the producers, to make their things fair. And we're also hooking up with knowledge graphs like OpenAir DataSite in order to be able to kind of build an understanding of where these workflows are being used and who is making them. One of the rules of the guidelines of FAIR is that the metadata and software had to be associated with detailed provenance. And here that particularly ties into versioning and the evolution of workflows, because they don't just land there and then get used, they get versioned and updated, they get hacked about, they get cloned and remixed with each other or remixed in with other workflows. So we had to provide all sorts of other infrastructure like registering versions, versioning the identifiers, tracking authors, lifting out sub-workflows, monitoring the workflows, so, and gathering together things like the supplementary materials, test data, and so on. So we've had to build quite a lot of infrastructure for that. A key point of FAIR is the workflow has to be accessible. So here we can retrieve the workflows by their identifier, and we can do it in a whole bunch of ways. We can view them on GitHub. We can run them directly by using the Global Alliance for Genomics and Health API. So here the Galaxy project and the Workflow Hub have implemented it. So you find a workflow in the Workflow Hub, and then you can launch it on Galaxy Europe straight off the bat by pressing a button. So that's handy. This uses the common workflow language here. That isn't a workflow using native Galaxy description. It's actually also been converted into the common workflow language, because we have to build a metadata framework for our workflows, because that's a fundamental of FAIR. It's metadata for machines. That was the whole point of FAIR, is human and machine readable metadata. So the first piece is a common workflow language. So we've chosen the common workflow language to represent a canonical description of the workflows. And that can also be linked to the containerized tools, which is really helpful for standardized knowledge transfer. And it's neutral to the workflow engines. So effectively, you can create kind of portable, reusable workflows regardless of the workflow engine, and that kind of avoids vendor and project locking. And here's an example of a workflow that's in Nextflow, which also has a sister described in the Common Workflow language. Rob Finn from the EBI, from the Magnify group, specializes in metagenomic workflows, and he uses the Toil execution platform, but he writes all of his workflows as blocks in the Common Workflow language, and then puts them together in order to be able to create his pipelines. That has the added advantage that when he needs to exchange, say, an assembly pipeline like Megahit with Volker Meyer, who's at the Argonne National Laboratory, who uses a different system he uses, or as part of the MGRAST, you can just pass it over and run it. And that's exactly what they did. So this is a really powerful indicator of why trying to work on these kind of more canonical descriptions using workflow descriptions, these abstract descriptions, is really, really helpful. And that uses the separation of abstraction from the description of the workflow from its execution framework. Well, then we also need to be able to describe what the workflow is about, what's its tools and parameters, in order to register it in Workflow Hub and to also exchange it amongst other workflow services. And we use bioschemas for that. So that's a version of schema.org. The only piece that is bioinformatics specific is the EDAM ontology, which provides a type system for the inputs and outputs. And then the final piece is we pull all this together in order to be able to package a whole workflow, all its metadata, all its companion objects, so that we're able to exchange and archive and report and cite it in a FAIR digital object called the Workflow RO crate. And finally, we want to be able to run that workflow and then keep its history. And there we use the EOSC Life prov description. I'll try and talk over whoever is playing this background. So this is actually all these communities, these workflow, the Common Workflow language, bioschemas, RO crate are all open communities that anybody can join. And that was an important piece of the EOSC Life mantra, which is that we would bring in and we would use open communities. We wouldn't reinvent communities. So here's an example of us using the bioschema. It's a lightweight metadata mechanism for being able to just describe what is a workflow profile and what's a formal parameter. It links out to things like organizations and licenses and to pre-existing ontologies. It's kind of an opinionated use of the markup mechanism used by web search engines, and it's increasingly used in science as well. It's also used in the Elixir registry for tools. And if you want to know all about that, you need to speak to Alban and Hervé, who really lead that activity. And then finally, we need to be able to package all of this stuff together. We need to create these kind of workflow objects. And that has to be really work regardless of where everything we're packaging together lives. So there we use something called the RO crate, research object crate. And that's a format for packaging together stuff that's scattered about, so that you get an integrated view of it. And you basically, it's a bag of metadata and identifiers. And those identifiers can reference workflows and data and people and places and mice and other things. It's just a packaging mechanism, but it's a very powerful mechanism. It's web native and off the shelf, so search engines and developers like it. It's infrastructure independent, so our ecosystem of environments and workflow management systems and services like it. It just uses JSON LD and schema.org and standard archive formats. And it's extensible and open-ended to cope with all that diversity of different workflow systems and different requirements, and to deal with all the legacy of having to develop a metadata framework to carry all this FAIR metadata, but in an environment where it wasn't previously expected to do so. And there we use duck typing for making profiles. Duck typing is if it quacks like a duck and it waddles like a duck, is a duck. So that's how we do our typing, by just describing what you might expect. So we have a whole bunch of these kind of RO create profile variants, which basically says this is what I expect to see created up in my package. There's a whole kind of world of data ones from, using in Zenodo and OpenAir and various different other projects, but we're particularly working on the workflowy ones, which are to do with testing and running workflows. And also there's a whole branch to do with regulation. I'll briefly mention that one because biocompute object is a regulatory mandate of the US Food and Drug Administration. It's a standard, IEEE P2791 standard. And this is really dedicated to describing high throughput sequencing workflows for precision medicine, where it really describes how to use it and when it is safe to use. So it's recognizing a computational workflow as a regulatory instrument. And that's very interesting. And there they have their own sort of way of describing that. So in a workflow that is agrees to this, you have both the RO crate and the biocompute object format sort of sitting alongside each other. That's called sidecarring. The reason why I talk quite a lot about these RO crates is because they are the first step towards something called FAIR digital object middleware. And that is actually a core piece of the European Open Science Cloud. It's a fundamental of the interoperability part of the European Open Science Cloud. If one reads this interoperability framework, you'll see it. And there's something called the FAIR Digital Objects Forum, which is really kind of trying to develop the notion of that. So these RO crates, and what we've done in EOSC Live is built perhaps the first genuinely example of FAIR digital object infrastructure. So that's it, we've got everything. We are lightweight, FAIR semantic workflow underwear, because it's all under the hood. Hopefully no biologist will ever see it, because all just to make everything work is now ready. So we can collect metadata, we can move it around, our workflow systems, our testing and monitoring frameworks, our general execution systems. We need to automate that metadata as much as possible, because nobody will ever really put it in by hand. And we need enough metadata, so if the workflow never worked again because all the software went away, we would still be able to understand it. And the framework that we've actually developed means that even if our workflow hub disappeared, this crating up archive preserves all the metadata and workflow together, and we're able to put it into something like Zenodo as a long-term archive. So to finish up, that was quite a lot about metadata. What about it being usable software? Well, of course, we're all familiar with containers and packaging, and I already mentioned things like being able to execute news run on things like an instance like Galaxy. But what about making sure it actually still works? Well, we had to build in EOSC Live testing and monitoring platforms like Life Monitor and OpenEbench that really kind of check out, does this thing still work? Testing that works with multiple back ends to make sure that the workflow is still fit for purpose. And we can download these RO crates from a workflow hub and give them to other systems like Schema, or we built a system called Workflow XS, which is basically a back-end service, so that you're able to, if you take one of these crates, you can implement it, you can run the workflow in a safe environment, particularly for sensitive data when you're dealing with patient data. But I won't go into those details. We also need to worry about the detailed provenance, not just of where the workflows came from, but what happened to the data when you run one of these. And that turns out to need a heck of a lot of different reporting if you're really genuinely going to keep the provenance in order to do genuine reproducibility and genuine repeatability. For discussions about that, I encourage you to attend this workshop on provenance for transparent research, which happens in a couple of weeks, and it's free, so even better. And then finally, there's this special thing about workflows, which is to do with their composability that I mentioned. So we need our workflows components to be reusable, i.e. they can be understood and modified and built upon, as well as the entire workflow itself. So we need things to be richly described, we need sample inputs and outputs and so on. But we also need our components to implement standard APIs and work with standard community metadata so that we can properly link things together. That means making tools workflow ready, wrapping tools, building these kind of canonical workflow blocks that I mentioned before. And this is not trivial. If you have different tools with different licenses, the combination of them is a mess. Moving things from local installations to global installations mucks up your identifiers. There's all sorts of things going along there. But primarily, we need to design for fair data and design for reuse. And people don't do that. They don't design their tools so that they'll be used in a workflow with other tools. They design them just for what they want to be able to do. And that has to be a sort of shift if we really want to do genuine composability. And so we've seen examples here. For example, the BioExcel project is making these kind of canonical workflow blocks that interoperate between any workflow language, and communities like NF Core and the Intergalactic Workflow Coalition and even DocStore provide infrastructure and mechanisms and best practices on how you should be doing your workflows, perhaps even a step towards certification of workflows, certainly a step towards community review. So to sum up, I really want to talk about the fact that all these things that I've talked about with FAIR is it takes a village. In order for data to be fair, you need a whole bunch of services and a whole bunch of stakeholders and actors that enable that FAIR. So it's a sort of joint responsibility and joint opportunity. If you have a tool, be a good plug-in tool citizen. And I won't go into the details of what to do, but just basically think about, could it be plugged into a workflow system? And as a workflow maker and user, we also have to be good workflow makers. Are we making identifiers for the data in our workflows properly? Are we licensing the outputs? Are we validating the parameters? Do we provide test data? And if you're a user, are you crediting the makers of the workflows that you're using? And of course, to make all this work, it's not free. FAIR does not equal free. So we need infrastructure providers and policymakers in order to be able to work with us on sustainability, of maintaining these kinds of infrastructures. And we also need stewardship around crediting and around certification and around building standards and practices and curating these workflows, as it were. But they're an important and crucial entry point into all the different tools and data sets that we're producing in the European Open Science Cloud Life project, and they're important functions for FAIR. So it's worth the investment because the potential is awesome. So this is my last slide. Sarah will be delighted to know. And it's basically a summary that says, Well, modern bioinformatics increasingly leans on computational workflows as both workhorses and as examples of transparent processing. And I think I maybe have got across this idea of democratization of access to data and infrastructure. They are hybrid digital objects of scholarship and should be respected as such. By making a big effort to make our workflows fair, it's a necessity, I think, to get wider uptake of them. If you can't find them, you don't understand them, you can't use them. But it takes a village where everyone shoulders responsibility, and that village is EOS Glyph as one example. And I'd like to thank all of these people who have helped me along this journey. So thank you very much, Sarah.
Thank you, Carole. So we have plenty of bravo coming from everywhere. You don't see all of them, but we have other channels, French. So we have several questions, and I will try to take some of them that are a little bit high level, and then we'll see for the other. So we have question about shouldn't FAIR workflows become a requirement for funders, you know, just like data management plans, to facilitate their adoption despite the steep learning curve associated with them?
So that would be lovely. I'm still working hard to make sure that FAIR data is mandated by funding agencies, and moreover, that it's actually also monitored, because I think pretty well every funding agency that I know of says we should have FAIR data, but they have absolutely no mechanism of being able to monitor it. And so in principle, yes. In practice, I think it's going to be a long journey, and I think as much as possible, we could try to do it in our communities, as well as not expecting to be made to do it. Now, I know that's tricky. I learned something yesterday that academic communities and research communities, getting them to change is like getting change in a cemetery. You don't get much help from the people inside. And I think that's really true, that it seems that the drivers are publishers and funders that really make an effort. But I think we should, again, take responsibility ourselves, Sarah.
Yeah, you're perfectly right. So we have several people who are eager to know more about, is there any really usable tools to, in a sense, assess the level of fairness of software and workflows, and how practically can it be done?
To assess the level? Yeah. No, I would say.
I had the answer, but
because I would say the FAIR principles for software are still being cooked. They're still being cooked by the Research Data Alliance and its working group. There are some ideas about what it should be, and they have a draft out, which I lent on heavily. Dan Katz is one of the leaders of that. For workflows, it's really right at the beginning, where we're probably one of the few that are really working this area. There is a group called Workflows.RI, which is led out of the US, that is also interested in FAIR workflows, and DocStore is another a workflow registry that we work with, particularly coming out of the Canadian world. And so we're all beginning to work on sort of FAIR workflows, but it's really early days. So we're still figuring out what does it mean before we even do any kind of automation around it. By the way, I don't really think that there is there's some metrics around FAIR data, but automatically figuring out whether data is fair is still a little bit off the way as well. It's still pretty well manual processing, Sarah.
Yeah. So very much more specific question, and at the end I may pose you a larger question. So on the specific question, you mentioned that there will be an event on July 22nd, and they were asking if you could show.
Yes, here it is. It's a workshop on provenance for transparent research. It's part of Prov Week. Prov Week is an entire week where there are a whole bunch of provenance conferences, TAP and IPOR, which I think Sarah, you've published in those forum, I believe. And this is all about what does it mean to do anything to do with provenance, particularly in the research and scientific world. And we have a workshop associated with that Prov Week, which is called T7 because it's about transparent research. And we have negotiated that that workshop is free and open to anybody. And it will be mainly about discussion. We have, I think, 5 papers or short papers, but they're very short. And the majority of it is to discuss issues to do with what is the point of provenance in science. Do we really mean provenance or do we mean transparency? What is fair enough? Because, you know, you can go a bit overboard. And have we spent a lot of time collecting lots of provenance information that nobody uses and not collecting the provenance information that everybody needs? So that's what that workshop is about. And hopefully you've had enough time now to write down the URL.
Thank you. A question, very specific question, but I think other people could answer in the room. Would you suggest any conda or container system for R?
For R?
Yeah.
Well,
we'll have another session.
Not really.
Yeah. So let's say for everybody that we will have another session at 3:30, where you will have, let's say, access to people definitely working technically on those domains, and that would be probably the better place to pose those kind of very specific questions.
Well, that's a very, so the containerization, I think it's again like, it's, my experience is it depends on not just the technical aspects, but on your skill set, who else is using it. So I don't know if it's there's a best one. There's just favorite ones.
Yeah.
So I mean, I'm wearing a t-shirt at the moment, which you can't see, but it applies here. So it basically says there are only 2 kinds of programming languages: the ones that people complain about and the ones that nobody uses. And I think that's the same with containers. There are only 2 kinds of containers: the ones that everybody complains about and the ones that nobody uses. So I don't know if I would be brave enough to say what is the best for any particular scenario, particularly as it's a kind of bit of a moving field at the moment, I would say. So lots of people are moving away from Docker to Singularity, for example. There's also been a lot of brouhaha around Docker Hub, you know, now no longer supporting long-term registering of Docker containers or Docker images, unless you pay, which I think is fair enough because they're a business. So that's why we have at the bottom there archiving containers actually on that slide, because your images expire and they go and that's it. You're no longer reproducible because it's disappeared off Docker Hub. So I think some of these things have a thing to play when you're choosing your platform.
So thank you. Are you going to our session? Are you still staying in JOBIM, or do you have to leave? Just to know where...
I have to now go and speak at the plenary panel at the JISC CNI conference on digital libraries and their role in research. So this is what comes of being a multidisciplinary researcher. Sarah, I now flip to a library conference, which is full of folks from the library. Did you want me to tell them anything they should know?
No.
feel free to tell me what I should say. So I doubt it very. I can stay for a little while, but not for very long. You have a great session in room 1 on open science, interoperability and bioinformatics.
Yeah.
And
Anyway.
given the recent announcement by the ministry, that would be a very interesting workshop to be.
Yes, definitely. So again, Carole, thank you so much. Again, your talk was particularly interesting for all of us, and we are very happy to, we are hoping to have you physically with us sometimes, so maybe to visit Paris or again.
That would be lovely. Be
Great.
very, very nice. I do,
So,
you know, love.
I clap.
Thank you very much.
You know, we never clap, so.
Oh, okay. So thank you very much, everybody, for inviting me, and sorry for overrunning a little bit to our next speaker. And yeah, thank you.
Thank you, Carole.